In our Sapphire Kingdom Gemology video channel, this is the lesson number 65. The topic is identifying gemstones with some tools. This is one of a tool, very important. This is fiber optic light. Come here, and the light goes through the stone, and we can see from here the absorption spectra. So the name for this is spectroscope. We are moving to the lesson. In this lesson, we are identifying gemstones with some tools. The main two tools I will explain here. One is spectroscope. The other one is refractometer. For the first one, we are looking absorption spectra, absorption line. This is the normal spectrum. Red, orange, the 7 colors are here. The visible light colors. In this colors, this is the green section. No, sorry, this is the green section. This is blue section, yellow section, red section. Inside the blue section, the sapphire absorbed the blue color here. So we can see it is blank. Blank means black color. This is black line. So we are discussing later. First of all, this is the theory. You need to understand this. I need to explain this gray color area. Gray color area shows the electromagnetic wave. Electromagnetic wave. I explained earlier lesson also. This is electromagnetic wave comes from the sunlight. Out of this big area, this is the smallest gap we can see, visible area. So this is only the visible area from red to here, invisible. And the violet to here, green, blue to here, all are invisible. Invisible section, left side and the right side. Right side invisible section, near the red color, visible red color, it is infrared. IR means infrared. Next, microwave. Next, FM to AM. All are radio waves. This range is radio waves. After that, the lone radio waves are there. Come to the left side, near the blue color, it is UV, ultraviolet. Then X-rays. Next to X-rays, gamma rays. This is the Greek letter gamma, gamma rays. If we discuss about the power of this electromagnetic wave, frequency is increased into right to left. Look at the right. The unit is hertz. 10 to the power 0, 10 to the power 2, 10 to the power 4. Likewise, 10 to the power 24. Then this range you can understand the frequency of the wavelength. Then the visible area is near this very small area. This harmful waves are absorbed by the ozone layer inside our globe. So out of this whole power, the visible area comes to our eye. So the living things are here because of this visible light only. These harmful waves are not coming through the ozone layer. It is working as a filter. So the color is, this is called color spectrum. The top side is frequency and the bottom side is wavelength. Wavelength is gamma. It's also Greek letter. Gamma measurement is with meters. So the visible area here, very big wavelength, 10 to the power 8, 10 to the power 6, 10 to the power 2 is 100, 10 to the power 0 is 1. 10 to the power minus 2 is 0.001. Likewise, 10 to the power 16 minus 16. So you can learn this, you can understand this. So it is wavelength, this is frequency. There are two things. Frequency is increasing from right to left, but the wavelength is increasing from left to right. So this is the power we need to discuss. Out of this power, we can sense only the visible spectrum through our eyes. Some cases in gemstones, they will absorb some colors inside here. We are going to measuring that absorption. After absorption, we can see the black line. So we are moving to next. Now we need to discuss this. Try to understand well. Lines and bands after the absorption by the stone, we can see A, B, C, D, E, F, G, H. There are lot of things here. A is this line. If we can visible A is the fluorescent line. A is fluorescent line. B is fine line. C is intense line. D is doublet, double line, doublet. E is narrow band, narrow band. Broadband, F is broadband. G is general absorption area, big area. A cutoff, H is cutoff. We can't see this. So these are the things we need to understand when the stone absorbs some color. We can display, we can see it here. So that is the measurement. This is the spectrometer. There is a stand, but we can see this easily with the hand, without stand. We can use our phone torch, and we have to stick the stone to the phone torch flashlight, and you have to cover the area between the stone and the flashlight. You can use some clay or something to cover that area. Then after that, you can on the torch switch in your phone, then the light is going through only the stone. Then you can see it through this spectrometer. Then this is absorption lines. If we see the natural red spinel, these are the black lines we can see. So you can understand what is it. See, B, like B, fine line. O, intense line, BOC. Then it is natural absorption lines. We can see here, the others no line. It is natural red spinel. Red color is absorbed. Then what is this? It is synthetic red spinel. If it is synthetic, there are some absorption lines here, very thin. And this also very thin. See the difference between red spinel, both are red spinel, but this is natural, this is synthetic. So with this spectroscope, we can see the red spinel is natural or synthetic. What is here? See the absorption lines or areas of some gemstones. See the ruby, red color, more lines here, weak lines, intense line. In blue area, because it is sapphire, so the blue area also absorption, two lines, double lines. It is ruby. If it is sapphire, this is the thick line, absorption line. So it tells us it is sapphire. What is this? If it is emerald, these are the lines. These are the lines. If it is almandine garnet, these are the lines. So we can see easily separate these four stones. If it is circle, these are the lines. 1, 2, 3, weak. Another line in yellow area. These lines in red area, orange area. This is yellow area. And the green area also some lines. Very fat line here. So many lines you can see like circle. If it is like this, we can see, we can tell it is a circle. If it is peridot, green color one, green color stone, not in Sri Lanka, peridot. There are 3 lines here. Then, if it is spinel but synthetic, see the synthetic spinels. Here, synthetic spinels, and here, red synthetic spinel. See the lines, 1, 2, 3, there are a lot. This is cobalt mix blue paste. Cobalt mix blue paste, not the stone. So see the absorption spectra. Now you can understand what is checking. Now look here, ruby, sapphire, emerald spectrum, almandine garnet absorption spectra, peridot, zircon, synthetic spinel red, blue paste, cobalt. But this synthetic spinel is cobalt spinel. Synthetic cobalt spinel. Then the blue paste, cobalt is there. See the difference. So red paste, if we use red color paste, we have to use selenium. Element name is selenium. It is red paste. If we use it, this is the red paste absorption spectra. Now look at the sapphire here. Zircon, emerald, ruby. Try to understand. Another one, short wave light, long wave light. This is 300, this is 700. 300 to 700 is the limitation of visible light. 3 to 500, 600, 700. Not 300, sorry, 400. 400 to 700. 400 to 500, this is 500, 600, 700. This range is the sunlight range, visible sunlight range. We learned earlier. Then the emerald is like this. See the absorption spectra in the blue area, red area. Here in this diagram, these diagrams, red color is in the left side. This side, right side, both are same. We can use any of the side. So, emerald shows red area, orange area, between red and orange area, here, absorption lines, and the blue area also. Ruby, blue area, there are 2, and red areas here. These are the visible area. Hone, another gemstone. It is like this. So these are the absorption spectrums of some stones. This is advanced tool to measure to see the absorption spectrum. Advanced tool. This is the gemstone. The light comes through the gemstone and slit is there. Slit is there. From this slit, it is coming through this lens and it goes through the prism. Then it converts light and normal light goes through this. Normal light goes through this. Then it gives the spectrum and we can see the absorption spectrum from here. Observer can see natural or synthetic ruby like this. These are the absorption lines. Another lines in blue area. Red spinel. These are the lines. Then you can see the difference between the red spinel and the ruby. Sapphire gives here. All the sapphires, they absorb this blue color. It is blue sapphire. The absorption spectra is here. Blue area, it is given like this. See, this is sapphire. This is sapphire. It absorbs this. Right. Now I need to show you this is the gemstone. The red color is the light. Light comes through this way. This is the point. If it is not the stone, if it is the environmental air, the light goes in this way. But the gemstone is bending the light. The light ray is bending. After bending, we have to check the amount. So when we draw a black line here, then this angle is I. If it is I, angle between that black color line and the bended line is R, angle R. Then there is a proportion. If we measure this in like angle degrees, sine value of that degree, sine I divide by sine R is equal some value. It is unique value for the media. In here, the bending media is a stone. So the stone's refractive index O, take the first letters R and I, Ri. Ri means sine I divided by the sine R. It gives some value. It is unique value of the medium. So the medium here is corundum or gemstone. So the gemstone's Ri is checking like this. Right. We are moving to next. To check the Ri, this is the apparatus. This is the tool. The bottle you can see, methylene iodide is there. Methylene iodide we use because the refractive index, so Ri of the methylene iodide liquid is 1.80. We use that with this tool. This is opening hemicylinder. This is called hemicylinder. We can open it. We are watching the stone from here. This is the eyepiece. This is the light source. There is a hole here. We can put the light here. Then we are moving to inside the tool. This is the inside tool. Look at that. When we open the hemicylinder, there is a glass here, and you need to put the methylene iodide single drop on the top of this glass and put the stone. If it is a cut stone, cut and polished stone, the polished facet have to touch the hemicylinder, inside the hemicylinders, methylene iodide drop and the glass. So the stone contacts with the glass through the methylene iodide drop. If it is not if it is a rough stone, we need to polish one single facet to do this. Then that polished facet have to meet the glass with the methylene iodide. Then after that, we have to close this. In some bigger stones, if it is very big stone, that means we cannot put inside the hemicylinder and close the cover. Without closing cover, we can't check this. So we have to close the cover. So if it is a big one, you have to take single part after broken the stone. You can break the stone to small piece with unwanted area from unwanted area. Then after that, polish one facet and take it to lab. Then if you have the refractometer, you can use it here. Then we are moving to next. See, the top side down. That means the big facet, polished big facet is the table. Table is touching the glass with methylene iodide drop. So this is the hemicylinder open. Then we have to close this hemicylinder. Then after that, this is the light. There is a hole in this side. Then the light goes through the hole inside. Then we can check from here. This is the eyepiece. When we see it, the calibrated scale is inside the machine. We can see it like this. Then you can see here the little darker area and the brighter area is separating from here. The separating place you have to count. 1.70 is this one. Then 1.71 is the next line. Next line 1.72. Next line 1.73. 1.7. No. This is the increasing from top to down. Then this is 1.65. Then the next line is 66. Next line is 67, 68, 69, 70, 71, 72, 73. That is the way. Now, can you guess the area, separating area from the darker and the lighter line separating area? I can see 1.715. 1.65, 66, 67, 68, 68 and 69. Between 68 and 69 or 68. So when I see keenly, I can see 1.6 is this is the place separating the darker and the brighter area. That is the measurement, RI measurement. So the RI of the stone we put here is 1.68. That is the way we are checking. So here, what is the difference? This is the light. This is the open hole to send the light. Then this is the eyepiece. After closing the hemicylinder, the light goes through the stone and comes to our eye. Giving this calibrating scale, darker and lighter area. So I can see 1.61 is 1.60 is here. It is 61. This is 62. Then the 1.62 is the separating area. From 1.62 to top, it is darker. Bottom, it is lighter. The margin is 1.62. Then the RI of the stone we check is 1.62. If you forgot to subscribe, like and share. Then we are moving in the next lesson. We are learning how we can see colors with our eyes. Very important lesson. How we can see colors through the eyes. This is very, very important. So in next lesson, it is lesson number 66. We identify that. Then, so after we are meeting in lesson 66, please subscribe and share.